Chapter 10 is the culmination of everything we've done this year. Whole numbers, decimals, fractions, mixed numbers, improper fractions, negative numbers. It's all going to come together now. So there are 3 lessons in this chapter. The first is rational numbers. A ratio is a comparison of 2 numbers, a and b, which can be written as a fraction a over b. It's also division. Remember, fractions do represent division, so a divided by b is what we're talking about. A rational number is any number a over b where a and b are integers, so you're still not allowed to have decimals in a fraction, and b, the bottom, the denominator, cannot be 0. There are a bunch of types of numbers, classifications, and they kind of nest together. So for us this year, everything is rational. Yes, there are numbers that are irrational, and we will deal with those next year in pre-algebra. Rational numbers are any number that can be written as a fraction, but those can be regular fractions, mixed numbers, decimals that end, decimals that repeat. Everything for us is a rational number this year. Now, there are stricter names and groups. Everything is rational. Below that are the integers, specifically the negative numbers. -2 and -16 are shown in this circle. If you have a negative number, it is both an integer and a rational number. That's why these are in circles inside of each other. Below the integers are what are called the whole numbers, and you see the only number in there is 0, because it is the only whole number, sorry about that, it is the only whole number that is not also a natural number. And that takes us to the innermost group, the natural numbers, which you will hear referred to as the counting numbers. Those are the numbers we count with. 1, 2, 3, 4, 5, so on and so on. What we do is we get to the deepest group we can here, and you belong to that group and every group outside of it. So I like to ask a couple of questions. My first question will be, do I count with you? If I say yes, then you belong to the natural numbers, and that means you're also a whole number because you're inside that circle, and you're an integer because you're inside that circle, and you're rational. My second question is, are you 0? Because 0 is special. It's a whole number that's not natural. It is also an integer, and it's also rational. I then ask, are you negative, but with no fraction or decimal? If you are, then you're an integer, as well as rational. And like I said, this year, everything is rational. So determine which set or sets each of these numbers belong to. So 68. 68 is a number you count with. You can count up to 68. So 68 is natural. If you're natural, you're also a whole number, you are also an integer, and you are also rational. And you can see here I'm using abbreviations. You can feel free to use these abbreviations as well. I don't need you to write those words out. But we use NAT for natural, WH for whole, INT for integer, and RAT for rational. The next number is -9. We don't count with -9, and it's not 0. So it's not natural, it's not whole. It is a negative number that doesn't have a fraction or decimal part. So -9 is an integer, and that means it is also rational. 7.80 is a decimal, so I don't count with it. It's not 0, it's not negative. Anything that's a decimal is just rational this year. The next example is here just to make sure you are paying attention to some things. 15 thirds is a fraction. Fractions usually make you think rational. However, 15 thirds is actually the number 5. And when we know that, we have to say, wait a second, 5 is a number I count with. So this is actually natural, which means it is also whole, integer, and rational. Zero is special. 0 is the only number that is a whole number that's not natural. So this is a whole number. It is an integer. It is rational. -7 thirds is a negative fraction. Negative means at best you're an integer, but the fact that it's a fraction means this is just rational. Next, write each number as a ratio. Means force it to be a fraction. So 15 as a fraction is just 15 over 1. -6 is -6 over 1. 5 1/4, we have to do our multiply, add diagonally trick. 4 times 5 is 20, plus 1 is 21, so that's 21/4. Same thing on the next example, we just carry the negative number with us. 8 times 3 is 24. 24 plus 7 is 31. So it's -31/8. 0.86, that's 86 hundredths. We can divide both of those by 2 to get 43 fiftieths as a simplified form. And 0 is basically a whole number, so we just slap that over 1. Name a number between 3/8 and 7/8. 3/8 and 7/8. So you can tell me 4/8, which is actually a half. You can tell me 5/8, or you can tell me 6/8, which is 3/4. With a number line, that's pretty easy to see. Also, you can literally just pick any numerator. We're between 3 over 8 and 7 over 8, so 4, 5, and 6 are between 3 and 7. That's the easiest way. Find a rational number between -5.2 and -5.3. So in order, they go like this. And it can be a little difficult to realize this at first, because there's nothing between 2 and 3. So what if I took those decimals and extended them both to say it's now -5.30 and -5.20? The decimal parts are 0.30 and 0.20. So literally it could be -5 point, and now you've got the choices of anything from 2,1 up through 2,9. Anything in between those two would work, including those two, -5.21 and -5.29. Last, we have find a rational number between -1 and 3/4 and -1 and 7/8. When you're asked to find a number between two fractions, or mixed numbers as the case may be here, we want to convert so that the denominators are the same. So the common denominator here is 8. -1 and 3/4 would become -1 and 6/8. Now, oops, sorry, I need to do that so it'll calm down. We need to get between those two numbers. Well, the fractions have the same denominator, so ideally we would just say, okay, what's between 6 and 7? Problem is, there are no whole numbers between 6 and 7. and you're not allowed to give me decimals in a fraction. So, there is a pretty simple solution. I'm going to leave the negative 1 part alone. But instead of 8, I'm going to double these up and make them over 16. 6 over 8 fully doubled up would be 12 over 16. And 7 over 8 fully doubled would be 14 over 16. The reason we do this is because now in our numerators we're looking at 12 and 14. And we all know what's between 12 and 14. So the easiest answer to this problem is negative 1 and 13/16.